G'day there. Well, today is a topic I'm really interested in, EVs, and how to charge them, particularly if you have renewable energy as a source. So I brought on an expert today. I got Ryan Hammond from Seal Performance Batteries. Okay, well, let's get into it. Welcome everyone to the final episode in this series of Solar and Battery Training, episode 13. Wow, what a series it's been for me every day doing this webinar for 1 hour. Now, I must admit, when I started the webinar series, I kind of thought it's only 1 hour. It turns out it's like 2 or 3 hours of prep, 4 or 5 hours of editing afterwards to get it up onto my YouTube channel. So basically my life has been this webinar series for 2 weeks now. But it's been really encouraging to see the support and enthusiasm from people out there. So thank you very much. So today, in the final episode, we're moving on to looking at EVs particularly. So I must admit, I'm not an EV person. I haven't got one. I'd love to have one. In fact, I'm planning to get one. So I brought in a guest panelist. So Ryan Hammond from Seal Performance Batteries. Ryan sells EV charging equipment. He's going to explain some of the intricacies around that. And Paul, who's my friend, who's an EV enthusiast, is going to help with the Q&A process because there'll be bound to be questions that I can't answer. So start posting those questions if you've got them already primed, or just throw them into the Q&A window as we go. So I'd like to introduce Ryan Hammond from Seal Performance Batteries. Over to you, Ryan.
Thanks, Glenn. And firstly, fantastic series that you've got running here on via web in these difficult circumstances. Gives everybody a great opportunity to log on and learn something new when they're either working from home or in self-isolation. So today I'll be, as Glenn mentioned, I'll be just having a chat about EV chargers and I'll be concentrating mainly on the AC side. So just bear with me for a second. I've got a short presentation that I'll run through, but at any stage, Glenn will jump in and stop me so we can answer some questions when they arise. So just bear with me. I'll just share my screen. So hopefully we can all see that. Glenn, that's all good?
Yep, all good.
Okay, fantastic. So just a little bit about myself and Seal Performance Batteries. We're an importer and wholesale distributor of energy storage products and batteries across a whole range of industries, which includes car, truck, automotive, recreational for caravan and camping, as well as residential energy storage products. We do a range of inverters, hybrid inverters, and of course, electric vehicle charging systems, which I'm here to talk about today. So we're an importer and distributor of Garo. And one thing I'll start with is that I'll use the term electric vehicle chargers throughout the presentation. The correct term is actually electric vehicle supply equipment. The charger as such is actually on the car themselves, not the device. These devices really just supply the power to the charger, in inverted commas, which is on the car itself. Garo are a Swedish company. They've been around for a long time, since the 1930s. They built their business around manufacturing plug-in vehicle heaters. So in Sweden, obviously during the depths of winter, it's quite common for vehicles to be plugged in when they're parked and get heat. So for them, it was quite a natural and easy progression to take that next step from vehicle heaters into vehicle charging equipment, and that's what their base is. The form factor of their base is around their previous vehicle heating systems. So they've been doing them for a long time. They've got a very large market share throughout the Scandinavian and Nordic countries in Europe, which obviously also have a very large EV population, if you like. So that's a little bit about Garo. What I thought I'd start with first is the options on the inlets, or what's on the options on the actual electric vehicles in terms of the charging options. And there's two different types of charging. There's an AC charging type, which therefore goes through a rectifier on the vehicle, and a DC charging type. And we'll talk about both of those, but in most cases, you're either a Type 1 or J1772, which is that top left. So they're quite common in the Japanese vehicles. So the Nissan Leaf, for example, and they're probably the most common type on your car that came in the early days. So there are still a lot of cars around with the Type 1 J1772 option, but as things progress, and it's become more and more common, and will become even more common for reasons I'll get to a little bit later, that the European standard is being adopted in Australia, which is Type 2, or the IEC, or the Menendez plug, which you can see there on the bottom left. One of the benefits of that is that the Type 1 maximum power you can deliver is 7.4 kilowatts. It can only be a single phase unit, whereas the Type 2, you can have either a single or a three phase unit, which allows you up to 22 kilowatts in terms of charging power. So that's the main benefit and the main difference between the two. But if you have a look at the EV, they'll either have a Type 1, or more commonly, especially in the European and newer ones, will have a Type 2. We then go across to the DC charging inlet or socket. Again, there's two. The most common one that we started with was the Chademo, and it comes out of Japan, Japanese, and up to about 50 kilowatts on a DC charging. So this is where the rectifier is actually built into the charging station. As a result of that, the infrastructure required for that charging station is quite a bit higher behind the scenes. The more common one, and again that we're moving towards, is the CCS, or combined charging system. Again, European based, and you can see there that it's essentially a Type 2 AC plug on the top with two DC injecting ports for the DC side. There's also the Tesla supercharger on the Teslas, which is a modified Type 2 Menendez. So they're the different sockets, if you like, on your cars, or inlets, like very similar to, you might have a diesel or a petrol. And one's if you notice the difference between a diesel and a petrol, normally the inlet is a lot smaller on one than the other, and this is very similar. But the most common question we get about these is, will there be a common standard? At the moment, the answer is no, but Australia is adopting more and more the European standard, and my understanding is that many of the EV manufacturers within Australia have decided that when they bring them in, that the Type 2 IEC option will be the one they bring in for Australia. So you'll see this more and more commonly in the EVs.
Can I interrupt you for a moment there, please, Ryan? I've got some questions.
Okay, can I? Will I just stop the sharing?
Actually, leave that screen back, just the one with the inlets, because I think this one relates to this picture, and then you can stop the sharing. So Gordon asks, I have a choice of charging my EV at home at 8 amps or 16 amps or 32 amps to 80%. Which is the best for battery life?
So that depends on the size of the battery, really. So the current rating of your charger then it directly relates to the amount of or speed, if you like, at which you're charging. So at 10 amps, and I'll get to that in a second. At 10 amps, you're charging at about 2.3 kilowatts, and so the time taken will take some time. With the lithium batteries, especially the newer ones, that are in the cars, in the vehicles. The speed at which you charge them, especially at that level that you're talking about, 8, 10, 16, 32 amps, really has no impact on the life of the battery. When you're talking fast DC charging, up to 350 kilowatts, then they cut off at that high power at normally around 80% state of charge for the batteries. So at the level you're talking about, with decent lithium batteries on the EV, doesn't really have too much of an impact on the life of the battery.
Okay, one more question about plugs. Louis asks, as with a Type 2 plug, a lot of installations don't have this current available on site. Is it adjustable to lower charge current?
Yes, it is actually. Well, I'll say that. I'll say so. With a Garrow, it is. With our EV charging stations, you can either set it by dip switch, so you can install a single phase 32 amp unit and then throttle the power, maximum power down to 6, 8, 10, 16 amps via a dip switch, or with the smarter versions, the Wi-Fi versions, you can actually set it via your app as well. Now, the other thing that you just need to be aware of is that faster isn't always better, and quite often the maximum charging power, if you like, is limited by the car itself. So, for example, I believe the older style Nissan Leaf and even the new one, I think the maximum they can take is only about 8 to 10 amps. So you might have a 32 amp charger, but the car will only be able to take the maximum of the 8 amps, and that'll be set up. That's part of the communication between the onboard on the car charger and your electric vehicle supply equipment. So they plug in. There's some communication that goes on before the charging starts, and they sort of set up what maximum power the cars can take. I hope that answers the questions.
Yeah, so actually there's lots of questions about plugs, so you really hit on a good slide here. So Raj asks, can the CCS charger be used for the vehicle with the Benekes adapter in the car? Yeah,
so the socket, and look, I have to admit I haven't seen one for quite some time, but the Benekes socket, that's the benefit of the CCS charging, the DC CCS charging, is that if you open the flap on your car, or you've only got one flap on your car really, which has both AC charging, which is the Benekes, and then DC, which is the Benekes plus your DC, complete all in one. So it's the same. That's the same socket used for AC, and the essentially DC. It's just a different plug type on the DC side.
Glenn asks, with the Type 2, the 3-phase, is it 63 amps per phase?
No, it's not. It's 63. It's actually total, so it's 22 kilowatts at 400 volts.
Yeah. Good. Okay, we'll carry on, and I'll interrupt you again. We've got some more questions.
Yep. So this is now the charging type. So I was talking here about what's on the car. These are now the charger, and so there's relating charger types for the relating sockets on your car. So there's actually, for the AC charging, there's actually 3 different types that you can get, even though there's only 2 different sockets on the cars. There's 3 different types of chargers. The first one is a Type 1 J1772 tethered. So it'll come with the charger or supply equipment will come with a fixed cable. So that's that one. And that type can only charge cars which have a Type 1 socket. Okay. So if you have a Type 2 socket, then you cannot charge it with a fixed Type 1 charger, okay, because the socket won't fit. The next one is a Type 2 or IEC mini plug with a tethered or fixed cable, okay, and again, if you've got a fixed cable on your charger with a Type 2, then it can only charge your Type 2 vehicles. So, So the ones with fixed cables are really designed for your installation in your home, if you like, or even at work, where you know what type of car you're going to be charging with. So Type 2 can only charge Type 2 fixed can only charge a Type 2 car. Type 1 fixed can only charge a Type 1 car. So the next question is flexibility. How do we get? Is there an option there to be able to charge cars with either a Type 1 or a Type 2 from a common outlet? And that is obviously quite a common question for public chargers. And the answer is yes. So you can get a Type 2, they're always a Type 2, with a socket on the charging station itself. Okay, so there's no cable, it's just a Type 2 socket. What that then allows you to do is charge a Type 1 from a Type 2 to Type 1 cable, like a crossover cable, or you can do a Type 2 from a Type 2 to a Type 2 cable. Okay, so they require, these ones are most common, public AC chargers will have a socket outlet for a number of reasons, which I'll get to in a minute, but the main one is flexibility. But what they do require is that normally the EV owner to have a extra cable in their car, which is, again, quite common. So if you've got a Type 1 socket in your car, then you'll have a Type 2 to Type 1. And if you've got a Type 2, then you'll have a Type 2 to Type 2 cable in your car that you can plug in to these common charging stations. Or there's others where you can actually get a cable yourself. So this is the only one, Type 2 socket outlet, which allows you to charge both Type 1 or Type 2 cars, but does require an extra cable. We then go across to DC, and it's a 1-for-1 essentially in DC. So if you've got CCS, you have to use a CCS. If you've got CharDemo, you have to use CharDemo. And normally they have an AC charger as well. But I've got a picture there. These DC charging stations are more like petrol bowsers, where they've got all the options there, and you just pick the one which suits your car. Again, similar to petrol or diesel in a petrol station. Okay, so again, the benefit, just going back to the AC one on the socket, so it can be a 3-phase unit, but when it charges to a Type 1 car, it's obviously maximum still only 7.4 kilowatts. So that finishes that one. Any questions there, Glenn, that you wanted to go through?
Yes. If you just want to stop sharing the screen for a moment. Okay, so we've got a question from Jonathan in New Zealand. He says, how does the onboard charger perform with proportional input like Zappy? No, I don't know what he means. Hope you do.
Yeah. No, I don't. Sorry. I'm not quite sure what that means. Sorry, mate. Maybe you can explain a little bit more.
Yeah, that's back onto you, Jonathan. David asks, do you know of an organisation that provides inspection and safety training for the commonly used electric vehicle supply equipment in New Zealand or Australia?
Do I know? I don't actually know, but I know that they're governed in Victoria essentially by the ESB. There are the relevant standard I'll get to in a minute, and there are wiring requirements around installations, which I'll talk to a little bit later. But in terms of the monitoring, the enforcement, then it's standard government bodies like ESB. For training, there's a couple of EV installers that we work with quite closely who can undertake training on installation and wiring, if that helps.
Thank you. So Ben asks, I think you've partially answered this already. Ben asks, if your car has a CCS socket, can you charge it using a Type 2 plug?
Yes, in AC. Yes, with the Type 2 AC, because it's the top end of it.
And finally, Rick asks, do you foresee a time when all batteries are standardized so that at charging stations we just swap batteries like gas cylinders?
Look, actually, that's an interesting question, and I think there was a company that was very early on, and they've gone essentially went bust. I can't remember the name of the company off the top of my head, but I'll do some research in it. And their initial business model actually was a swap out battery system. So their plans was originally to set up petrol stations, for want of a better word, or stations where you could drive in and do a fast swap of your battery system. Now, that's a great idea in theory. However, as the question alluded to, the difficulty is in standardization across car manufacturers. And it's just because each car manufacturer has different chassis and they put batteries in different spots within the cars, and they have different protocols and even different battery chemistries across all EVs. It just got to a stage where it was just not going to work. It was impossible to try and get some consistency across all EV.
Ryan, the brains trust out there have all chimed in. The company was called Better Place.
Better Place, that's it. Perfect. Yep. So there you go. That's exactly right. Yep.
Thank you, Peter and Wilfred. A cheeky question from Colin. Is it correct that Tesla chargers use a mechanical block in the charger plug to stop cars other than Teslas using them, while Tesla cars can use other networks?
So I have to be honest, I'm not too sure what Tesla used to block the use of non-Tesla cars on their chargers, but that's 100% correct. You can't charge a non-Tesla car with a Tesla charger, but you can charge a Tesla with a non-Tesla charger. Okay, so they have allowed it that way around, and they use it's a modified Menikes, so it's a modified Type 2, and that mechanical protection. You're probably on the money. I'm not sure how they use to block it, but that does make sense.
Righto. And Paul, my friend, he just typed in the chat window that Tesla did toy with the idea of swap out batteries, but looks like they didn't go any further with it.
Yeah, I think it's the difficulty in getting spare batteries around the world, and it's easy. You've got power everywhere, so a number of different reasons. I would think.
Okay, back to you then, Ryan.
I'll just share my screen again.
Yes.
Okay. So just a little bit on the different amount of power supplied. So we've spoken about the different types of chargers. Now I'll be concentrating mainly on AC charging through this presentation. As I mentioned before, DC charging requires quite a large investment and installation in the infrastructure behind the charging, whereas AC charging, it's a simple matter of wiring it up, as most qualified Sparkies could do. So that's what I'll be concentrating on through the presentation. So essentially, let's say our voltage is at 230 volts, single phase, 10 amp current option will give you 2.3 kilowatts. Okay. Now, what I've said here, a typical charging time for a 20 kilowatt hour battery Now, a 24 kilowatt hour battery, let's have a think about it. The Leaf, so full battery vehicles, 24 kilowatt hour battery would be considered quite small for a full battery electric vehicle. For a hybrid, plug-in hybrid vehicle, so there's two different types of EVs that I'm talking about here. Full battery, which has only got electric motors and runs only off batteries, normally will have a larger capacity battery on board to give you the distance, whereas a plug-in hybrid, so a Mitsubishi Outlander, for example, the plug-in hybrid will have both combustion engine and a electric motors, and therefore will have petrol as well as battery. And because you've got that petrol backup, the battery capacity is smaller than a full battery electric vehicle. Now, considering the average drive per day of an Australian to and from work is sort of that 50 Ks, even with a plug-in hybrid Mitsubishi, for example, where you can get sort of 80 Ks off your battery, very rarely would people utilise the petrol side of it. However, getting off track, let's say an average battery capacity on an EV is about 24 kilowatt hours. Okay, so if you utilise a charger that you get normally with the cars, which plugs into your standard 10 amp socket, or your standard wall socket, that'll give you about 2.3 kilowatts per hour of charge, and will take about 10 hours to charge a 24 kilowatt hour battery from flat, and you roughly get about 4 10 to 12 kilometres of distance per hour of charging. Okay, the next one up is say a 12 or 13 amps will give you 3 kilowatts, but we go normally 10 or 16 amp, and a 16 amp will give you 3.7 kilowatts, which will give you a full charge from empty, which isn't all that common, in about 6.5 hours. So again, you can imagine if you get up in the morning, you drive to work, might be 25 Ks, you come home and you plug your car in, and you'll get a full charge overnight, ready to go again. So the most common place we see people charging their EVs will be at home, and most commonly in overnight. If you go to the next one up, which is a 32 amp single phase, then you're then talking that same charge in about 3.2 hours. And then we go up to the 3-phase systems, which is up to 22 kilowatts, which is about 1 hour. Okay, so the main ones that we sell are either the single phase, and type 1 can only be single phase. So the maximum is single phase 32 amp, which is 7.4 kilowatts. So you've got a type 1 car, AC charger, that's the maximum you can install on your house. So the most common one we sell is the 7.4 kilowatt single phase, which is a 32 amp system, because it can be dialed down, or the 22 kilowatt 3-phase with the type 2 outlet. Okay, so that's the charging speed. As I said, faster isn't always better. In terms of even residential as well, we quite often get people who are in shopping centres, for example, or cafes or wineries.
Can I interrupt you there? We've got a couple of questions, and one of them relates to the slide that you just moved off.
Yep.
So, can we go back to that slide? So Will asks, what is the mode section column refer to?
So there's a different, if you have a look at the EV charging types, there are a number of different types or modes. Mode 2 is a plug-in. So mode 2 will have it's a portable unit with a protection and communication box on the charger itself. Okay, so it's you plug it into the cable. So it's the dumbest of the chargers, if you like. So the communication doesn't set up there between the EV charger and the car. Mode 2 is, so you go straight from your EV charger, mode 3, you go straight from your EV charger into the car. The communication is set up between the car and the charger, and away it goes. And then mode 4 is the DC.
Okay, cool. Jeremy asks, does Garo make any vehicle-to-home equipment?
No. And I thought this question might come up, actually. So this is a common question, and at the moment, I'm not aware of too many out there that have a vehicle to home, so back the other way, where you can plug the charger in, and that allows you to use your EV battery as a battery to supply your home. So Garo doesn't do it. There's been a lot of talk about it. They are working on it, but I'm not too sure of too many that have that up and running at the moment.
I can probably add something to that too, which is we currently don't have any standards that cover vehicle to grid. So you kind of will have issues connecting that because you're connecting a generating system to the electricity network, and there's usually tight rules around that, and there's safety standards required. So it may not even be possible in your jurisdiction, even if the equipment's available.
Yeah, I think, and as I said, I'm not aware. I know the CSRO were doing quite a bit of work on it, but I'm not aware of where it's at.
Here's a really interesting one. I never even thought about this, and this is about as we move to an EV world, which inevitably we are. Anonymous asks, are there any roadside assist for EV vehicles in Australia and New Zealand? And for instance, if you have a flat battery.
I know Tesla have one. They utilise a contractor at the moment. I had one of my business partners has got a Model X and had it completely shut down on him on the side of the road in Queensland. And one thing about when the Tesla, and I'm assuming all EVs, shut down, it completely shut down. So they actually the tow truck had to actually drag the car up onto the back of the truck because it was in lockdown. The wheels wouldn't even turn. So it was a complete lockdown. System just shut down. So that was a third party contractor who obviously then towed it to Tesla. But that was via the Tesla hotline call. I'm not aware of any others. I assume there's probably some out there that do it.
I think we should keep that a bit quiet. We don't want to scare the horses about range anxiety.
Okay. Yeah, it's an interesting one.
Okay, here's one from Jonathan, which actually is a clarification on the Zappy question. And it's specific to you. Does Garo have any chargers that use solar directly, or any brand?
That use solar directly?
Mm-hmm.
No, we don't. So my response to those questions is always that essentially it's just another load especially at your home. You have to have a dedicated circuit. I'll get to that in a second. Onto your EV. So if you've got a hybrid system in your home, a solar hybrid system with batteries, and you do plug in your EV when you get home and your house is on batteries, then the inverter would normally take care of the fact that it supplies the EV from your batteries or from any excess solar that you've got on your roof. Essentially, it's just another load. So if you've got excess solar and available to you, and you do plug your EV car in, then it does go. That excess solar will be put to charging your EV.
I do know of one brand, Solar Edge, have produced a PV to EV diverter. So it still uses the grid, but it preferences renewables where it can and blends the two. So you will be charging predominantly with solar when it's sunny, but it'll still charge your car using AC to finish the job.
Yeah. Okay. So and realistically, when you're charging at quite high speeds, especially if you've got a three-phase system, 22 kilowatts is quite a load, so it would normally be offset by the grid in any case.
Yes, I think it's all about how you use your vehicle, isn't it?
Correct, yeah.
Okay, I've got a few clarifications here. Brains Trust out there, thanks, Peter. Peter points out that the Dutch were trialling a fleet of Renault Zoo vehicles with modified CCS connectors to experiment with vehicle to grid. So it's already happening in some countries. It's just not currently legal in Australia. Peter also points out, and I think he's got one of these, a BMW i3 will go 5 kilometres past zero. So when it runs out, you still got 5 kilometres in the tank, as it were, and can be put into neutral. So it can be moved while in neutral, not dragged on locked wheels. So good old thanks, Peter, for pointing that out.
Yep.
Another one here, could an EV charger adjust load to match solar output? This is from Liam.
Theoretically, yes. You just need some communication there, and we'll get to that in about 3 slides time. Actually, I'll sort of. The answer is yes, and you can get devices that do specifically that, but I'll tell you how Garrow managed that.
Okay, I'll let you get to it then.
Yep. So I've just got here a couple of things to consider when thinking about installing EV chargers or EVSE. So form factor, is it going to be wall mount or ground mount? And is it going to be sort of undercover, or is it going to be out in the elements? We've got a couple of wall mount options with single outlets or dual, and they've got some more industrial, commercial IP65 rated. These are often installed in the snow that are curbside or car park side mount. So form factor is always an important one. And this is probably an important slide as well. And I'll start with the installation requirements. So they require a dedicated circuit. So on that circuit that you install your EV charger on, you cannot have any other device or power point. So it has to be, you have to run a new circuit from your load center or your switchboard directly to your EV. Okay, so it'd be like your air conditioner or your oven, for example. Obviously, correct cabling size to match the power output or the current carry capacity of the cable. You will need RCD or RCBO protection, which needs to break the neutral. Okay, so that's quite important. And this next one differs between Australia and New Zealand, my understanding, and there may be some guys in New Zealand who know this better than I do, so can add to this one. But type B, so if the charger itself does not have DC sensing built in, which the Garrow DC versions do, then you will need to install a type B RCD in some areas. My understanding is that it's highly recommended in Australia, but not essential. And I think Glenn will know the word for that in the standard. But my understanding is in New Zealand, it is actually a requirement that if you don't have DC, you have to have a type B RCD installed.
Yeah, you're right. So New Zealand's a bit stricter about the characteristic of protection devices. We're a bit
Yep,
easygoing in Australia. We kind of let fair bit of DC leak out.
yep,
So, so Type B are tolerant of 100% DC, so they can detect it and interrupt it.
yep. So that's the Garo DC versions. So that this rule it differs country to country, and Garo have recognised the fact that in some countries you do need Type B RCDs, and they're quite expensive. So they've added in a DC version which senses the DC and any leakage from DC and then protects accordingly, which means you don't need a Type B RCD. It complies with the DC sensing. But for versions which don't have the DC sensing, you do need to add a Type B RCD in New Zealand, especially, and recommended in Australia. Some other things to consider is single or three-phase. Obviously, if you've got it in your house. And the biggest one is your switchboard or your load capacity. So we quite often get the questions from car park, multi-level car park or shopping centre. Okay, we want to install 10 EV chargers on this floor, and we want them all to be 22 kilowatt versions. So that's 220 kilowatts possible if all EVs are charging at full rate all at the same time, that they would need to have in excess to their existing load in order to supply those EVs, which most don't have, especially a retrofit, for example, an existing switchboard. So the management of load then becomes very important, and there's a number of different ways that's done. I'll get to the Garo way in a minute. So that's one. The other one is what about at home as well? So if you've got a 32 amp EV charger at home and you've got an EV that can take all 32 amps, and you come home at night and you plug your EV charger in, most load centres in Australia, that the income is only a 40 amp max. So you can plug your EV in, and with the possibility of taking 32 amps, doesn't leave too much excess capacity or to be running anything else. So how do you take care of that with the whole goal of maximising the charge or maximising the charge power to your EV while managing the overall loads of your system? And there's a couple of different ways of doing that. That's a GLB home charger, by the way, which we'll talk to just a quick overview. But with the smart charger on home, you can get it's got Wi-Fi built in, which allows you to set the time of use, as do most cars, by the way, or quite often the cars, when you plug them in, you can set up a charging time on the car, but don't have that option on the car, then you can do it via the smart charger on your app. So you can set up the time that you want to, when the charger is enabled. So that's one option. You can then, it can also add in a smart meter in your switchboard or your load center, which then communicates to the charger itself, which then manages your load based on your total limit. So you can set the total limit to 30 amps. If the house is taking 15, then the charger will only then supply a maximum of 15 amps to your EV during the charger. So and then as the loads in the house decrease, then the charging speed on the charger to the EV can increase. Okay, so that can be set up via the app as well. And there's quite a few different nice little features with the app. You can monitor your power usage, etc.
Ryan, I've got a question actually from me. I'm rather excited by this slide. So if you have solar, this dynamic adjustment of charge rate, would that not respond to the fact that there's surplus generation on the site, and therefore if you set a very low consumption target, solar will be used first?
Yes, that would make sense. I'll have to think about that. Theory, yes. Yeah, I think it would. It's a smart meter. It's done via a smart meter on the incoming side to manage so it knows the overall load of your house, and then you set that maximum output on the.
So I've actually had Brains Trust answer that one for me. So Peter says the Zappy does exactly that.
Yep.
So yeah, and more,
okay.
says Jeffrey. So people like the Zappy by the sound of it, but it sounds like one of many solutions for managing.
Yes, there are. Yeah, and I think the idea behind this is that this is how Garrow does it. It does it in quite a smart way. There are quite a few other solutions out there as well. I know the sort of Delta utilizes the PLC for its dynamic load management. Okay, so this is in your home version. So when you've got one managing the load of your house. What happens when you've got multiple systems, for example, in an apartment block? And again, Garrow does it in quite a nice way, in that you set one up as a master, and it can be, all of our ranges can either be a master or a slave. Okay. And you set one of them up as a master, and then all of the rest connected below that via an RS485 connection cable, and they're all set with slaves. And in the master's connected to again the smart meter that sits in the switchboard, and in the master you can set your maximum load, and that then manages, the master then manages the whole system to that maximum load demand. So if you've got one, let's say you've got a maximum of 100 kilowatts, and you've got 10 EV chargers, and you can have a combination of single phase, three phase as slaves. But let's just say you've got 10 22 kilowatt systems installed. So the first EV comes along, plugs in, gets all 22 kilowatts. Second, all 22 kilowatts up to the fifth. Once the fifth one plugs in, then it'll manage the load down to 20 kilowatts each EV, and then so on. So it dynamically manages those loads based on your maximum allowable and the number of EVs there that are plugged in at one time. And
I've got a question that kind of relates to this time of use or dynamic load balancing. Can there be a charging time schedule to manage solar, peak power time tariff, off-peak tariff, or could you profile the charge sequence?
With the smart ones, you can. There's some timing that you can set up, so you can schedule the times. But that's done at the same time every day, if you like. So let's say you can set it up so that between 10 a.m. and 3 a.m., 10 a.m. and 3 p.m., you charge at 32 amps maximum. Between 3 p.m. and 9 p.m., you charge at a bit of a 6 amps, for example. And then after that, you're off peak, you charge it again later.
Thanks.
So yeah, back to this. So this is a very easy way of doing it. There's a whole range of different ways that this can be managed, and each manufacturer does it in their own way. I know Schneider has an add-on software for it. I know the Delta utilize a PLC, but this one is it's a very simple install, and configuration for the load management and dynamic load management with the Garrow. Just moving on, so that's the GLB range. This is a wall mount, ideal for home installation, for residential apartment blocks, multi-level car parks, etc. They also have the LS4, which is ideal for curbside mounting for councils, shopping centres, etc. And these have got two outlets. Oops, I didn't know that was there. So it's got two outlets, two socket outlets. Actually, that's this presentation will actually show the Garrow with a Tesla charger. Can you see that there, Glenn?
Yes, that's fine.
Can't hear it.
Yep.
But you can see the Tesla charging with the EV. So that's his socket. That's his cable. He plugs it in, and then plugs it into the car. There's RFID features. You can see the charge indicator, and there's an LS4 plugged into a Tesla. These particular ones are lockable and very easy to service as well.
I'm interested to see that the charging supply actually shows you your state of charge, so it's communicating with the battery.
Yes, it does. Yeah.
So that could be a source of charger rage.
Yeah. Yes.
You've left your fully charged Tesla in, and I can't park there.
Yeah. So this does it in the LS4 can do it in a very similar way to the GLB, but it's got quite a bit more smarts built in a couple of different versions as well. So you can do the load management via a back end for those that are aware. There are plenty of those back end software available out there, and they've all got a standard Open Charge Point Protocol, OCPP, which all the chargers with comms will have as well. And so there's the ability to do the dynamic load management by your back-end software via the OCPP. And you can see here a very large installation in an airport in Europe of the Garrow with one charger per two parks. So that sort of brought me to a close. Hopefully that's giving you some information. I've got 5 minutes there, which was not too bad timing, Glenn. Hopefully that was what you're after.
Yes. If you want to stop sharing, great. That's perfect. So we had some great questions there. Some of them I've answered by text, but actually the last one which I answered, I'll just throw it back to you, which is charging, is it done by the conventional process of rectification and transformers?
In terms of the onboard version?
Yeah. So what's in a charge supply station?
Oh, what's on the charge supply station?
Yes.
Not much, actually. As I said, on the AC version, all the AC version does is supply power to the rectification is actually done on the car in AC. Okay, so that's the difference between an AC charging station. All it does is it's just an AC supply with some smarts built in that just then supplies AC power to the onboard charger, for want of a better word, on the car, which does the rectification. DC charging, however, that then converts AC to DC within the charger itself, and then supplies DC direct to the EV. And I have to be honest, I'm not sure how that goes directly into the battery, DC to DC. And I'm sure there's people out there who know a lot more about that one.
Okay. Another question is, do some vehicles charge their own battery when they're braking?
Yes. Yep. Most EVs will have regenerative braking. So as you take your foot off the accelerator, most EVs will slow automatically, and that also generates power that goes back into the batteries as well. And so I was talking about the three different options. There's a battery electric vehicle, which the only way to charge the battery is via a plug-in EV charger, like I spoke about, or the regenerative braking, etc. Then there's a plug-in hybrid, and again, there's a combination of those which take regenerative braking, or when the combustion engine is going, sometimes that can charge the battery as well, depending on the vehicles, or a plug-in. And then the third one's the likes of your Prius, which is completely done via onboard. So that's not a plug.
Okay, another question. Anonymous says, does the car have to communicate with the charger for it to start charging?
On the mode 3, yes, it does. It does. And what you'll find, actually, what we learned very early on is that I mentioned before, if the EV charger or their supply equipment on an AC version, let's say it's got a Type 2 fixed cable on the EV charger. What we learned very early on is that you couldn't plug in a Type 2 to Type 1 cable into a EV charger that's already got a cable on it. So my understanding of that is that the standard state that you can only have one cable between the charger and your car. And so what happens is there is no communication and they don't start charging.
Right. Okay. I've got an interesting observation. I live on top of a mountain and I'm thinking of buying an EV. And a couple of my friends who have EVs pointed out that I should take advantage of living on top of a mountain and not fully charge my EV, because otherwise I'll have to use real brakes as I go down the hill, wear my brakes out and not benefit from any regenerative braking.
That's a very interesting concept. So you just roll down the hill to charge your vehicle.
Yes, it's a pity it's not an MC Escher hill where I can roll back up it again.
Yeah, that's a bit like that old way of generating power where you pump the water up the hill during off peak and let it roll. Use it as it goes back down the hill during peak.
Great. Well, we've come to the end of our time today and the end of this webinar series. So a big thanks to Ryan for turning up on a Sunday on his day off to talk to you guys. The slides that you've seen, Ryan's happy to share those. So I'll put a link in the description on my YouTube channel. For those who haven't joined these webinars before, these are recorded webinars. I then go and edit them. It takes me the rest of the day, basically. Chop out all the ums and ahs and put it onto my YouTube channel. So you can find these webinar series you search for Smart Energy Lab on YouTube. So there'll be a link to Ryan's presentation and his company on that in the description field. So once again, thanks to everyone. Thanks, Paul. I know you had a poor connection there, so Paul couldn't actually talk to us, but he was in the background helping me out with some answers to the questions. So thanks, everyone.
Thanks, Clive. Thanks, everybody, for your time as well.
Great. All right, we're going to cut the line now. See ya.
Well, this brings us to the end of this 13-part series on solar and battery training. A big thanks to all the sponsors who made this possible and my guest panelists. I'm thinking now of doing more of these webinars. It's been so successful. So I hope to see you back soon. Thanks a lot.